So finally in this last video is just a big example of applying the different techniques that we learned throughout this module. So this covers going back to just understanding z-scores and how to compare two z-scores to decide which one is better or which one is more unusual. This goes back to covering the normal curve rule, or that empirical rule that included the 68%, 95%, 99.7%, as well as finding probabilities and cutoff values. So with most of the other examples, I suggest pausing the video and working a part, and then looking at the video to see if you did it correctly or not. And then if you did not do things correctly, that'd be a good thing to maybe post on the discussion board or email the professor about. So for all of this example, we're working with the length of time that a customer waits in the drive-thru at McDonald's. It is said to have a normal model, so it has that bell-shaped curve with a mean of 91 and a standard deviation of 26. So things I already know is that my mean is going to be 91 and my standard deviation is going to be 26. So go ahead and pause the video here and try to complete part A, and then watch the video to see if you agree. So first for part A, let's see if our picture agrees. So I have a mean of 91 seconds. My standard deviation step size here is that 26 given to us early in the problem. We then have the key number of 117 seconds showing up in the problem, which perfectly falls right here. And since it said at least means that's the smallest value it could be, or it could be anything bigger. So that at least is going to tell me to shade to the right. So this problem specifically asks us to use that normal curve rule, or the 68%, 95%, 99.7% idea. The 117 falls perfectly one standard deviation above the mean. I know from this normal curve rule that 68% falls within one standard deviation in either direction of the mean. So that's where my 68% comes from. So I already have 68% on my picture. That means I have 32% left that I can add to the picture. So if I take that 32% that I have left, but I have two different spots that it could go between, and I divide that by 2, I'm going to get that there's 16% in this piece as well as in this piece. So now I already have my answer. My answer is going to be 16%. The last thing I need to do is interpret this probability. So then I can say that the probability that a customer waits at least 117 seconds to receive their order is 16%. Next, go ahead and try part B. So let's first see if our picture agrees. So I start with the same scale that I had up above, since my mean was still 91 seconds and my standard deviation was still 26 seconds. It then asked me for longer than 2 minutes. Well, first my other units were in seconds, so the first thing I did was change 2 minutes to 120 seconds. And therefore it fell between the 117 and the 143, but much closer to the 117. The longer then tells me to shade to the right. We're being asked to find a probability. So things I can think about for my probability. I'm going to need to calculate a z-score. Recall, if I plug in 91 into my z-score formula, I get a 0, because the mean is 0 standard deviations from the mean. So 117 is 1 standard deviation above, and the 143 is 2 standard deviations above. So my z-score is going to be between +1 and +2. Next, I know my answer is going to be less than 50%, because if I had everything to the right of 91 shaded, that would be exactly 50%. So I can tell that I have less than half of that picture shaded. Finally, since my picture is shaded to the right, I know I'm going to have to use my shaded right rule, or that 1 minus rule. So go ahead and next calculate your z-score. After calculating your z-score, you should have got a positive 1.07, which is right between our 1 and 2, like we knew it should be. Next, we're going to take this number to the table. And in the table, we find 0.8577. Because we were shaded to the right, and our table is shaded to the left, this 0.8577 technically represents what's to the left of our value. So for that reason, we have to do the 1 minus rule to get a probability of 0.1423. Finally, we just need to interpret that probability. So we then can say the probability that a randomly selected customer waits for longer than 2 minutes is 0.1423, or 14.23%. Next, go ahead and try part C. So part C is an example of working backwards. This time we want to find the length of time that 20% of drive-through McDonald's customers wait less than. So I want 20% to be less than whatever value I am trying to find. So remember that everything to the left of 91 would be 50%, so 20% would have to be somewhere below that 91. I more specifically want that to be a 20% or 0.20 in decimal form, and my goal is to find the value along the bottom. So things I can tell, my answer better be less than 91 when I'm done, which also means that my z-score is going to be negative. So the next thing I need to do is to figure out what to go to the table with to find my z-score, and then find my z-score. Since my table reads to the left, how much is to the left of my question mark? Well, it's 0.20, so I'm going to be going to the table looking for 0.2000. Again, I give 4 decimals since that's how many decimal places are inside my table. Finding the closest thing that we can on the inside of the table here, we find 0.2005, which then corresponds to a z-score of negative 0.84. Now plugging my values into my y equals formula, z is what we just found. Our standard deviation was 26 and our mean was 91. That should give me the answer of 69.16. Recall though, I'm trying to find the length of time, so my units here are in seconds. The last thing I need to do is to interpret this answer. So we can then say that 20% of McDonald's drive-through customers wait for less than our 69.16 seconds. Next, go ahead and try part D. So let's see first if our picture agrees. I have my same scale in black as I did earlier, since my mean and standard deviation have not changed. For this problem, I asked for less than 60 seconds or more than 100 seconds. So less than 60 would be smaller than or to the left, more than 100 seconds would be to the right. So this picture actually does look different than ones that I've seen before. But what I can do is treat this like 2 separate pictures. Let me first just focus on the piece where I'm shaded to the left of 60. I'm going to call that piece A. That's a shaded left piece. I know how to find that piece. So now pause and just find piece A. So if I just find piece A, my z-score I know is going to be negative. It's going to be between -2 and -1, which it does turn out to be. Since this piece is shaded left, when I go to the table, that's also going to be my probability. Since the table is shaded left, and I'm trying to find shaded left. Now, let's focus on this other piece, the one that's shaded above the 100. Let's call this piece B. That's a shaded right piece. I would know how to find its probability. So let's do that piece now. Now for this piece, since I'm shaded to the right, I know I'm going to have to use that 1 minus rule. Since my 100 falls between 91 and 117, I know my z-score is going to be slightly positive between 0 and 1, which it is. When I take that value to the table, I should find 0.6293. Now again, because this piece was shaded to the right, I have to do the 1 minus rule to get 0.3707. So I found my two separate pieces now, A and B. So to find my overall probability, we're just going to be able to add those two pieces together to give me my total probability. So I'm going to get a total probability of 0.4958. And now finally, I can interpret this probability. So I can then say the probability that a randomly selected McDonald's drive-thru customer waits less than 60 seconds or more than 100 seconds is 0.4958 or 49.58%. Next, go ahead and try part E. So first, checking our picture, I have the same scale on the bottom as I've had since the beginning. This time we're asked between 40 and 85 seconds. So 40 is just barely more than the 39, and 85 is slightly smaller than 91. This time it does say between, so we shade between it. So now our next step is to find our z-scores for both the 40 and the 85. So now calculating both my z-scores, notice they're both negative, which is because they're both smaller than the mean of 91. The 40 should be between -2 and -1, which it is. The 85 should be between 65 and 91, so between -1 and 0, which it is. Now for my between rule, my next step is to take both of these values to the table to find their corresponding probabilities. So my values that I found in the table was 0.4129 for the -0.22 and 0.0294 for the -1.89. Now my last step for that between rule is to now subtract those probabilities, the larger one minus the smaller one. So then my probability turns out to be 0.3835. Lastly, we can interpret this probability. So then we can say the probability that a randomly selected McDonald's drive-thru customer waits between 40 and 85 seconds is 0.3835 or 38.35%. Finally, try part F. And so first, some important information. We already had McDonald's mean and standard deviation from the very beginning of this problem. We're also given some additional information about Wendy's drive-thru wait times, and they have a different mean and standard deviation. Our goal is to figure out which observation is more unusual. So first, as a reminder, what does it mean to be more unusual? Well, in order to be more unusual, we're going to be far from the mean. Remember again, far is in quotes here because it's not necessarily the exact distance because I'm going to be scaling by the standard deviation. But what that's going to mean for me is I'm going to be comparing some z-scores here. And so whichever z is further from 0 will be the more unusual value. Again, do you remember why 0? Well, 0 is what we get when we have the observation equal to the mean, because then the observation is the same as the mean and it's 0 standard deviations from it. So whichever one is more unusual, be whichever z is furthest from 0. So now let's do our calculations for our McDonald's and Wendy's wait time. So now I have calculated my two z-scores. For the McDonald's wait time, I got a z of 1.07, which means that that wait time is 1.07 standard deviations above the mean. For the Wendy's, I got a positive 1.03. So this wait time is 1.03 standard deviations above the mean wait time. So which of our z's is further from 0? So our McDonald's time will be the more unusual. So to explain that, we would say the McDonald's wait time is more unusual as it is more standard deviations away from the mean. Again, for more unusual, I don't care about the direction, just how far away from the mean that it is. So hopefully through this example, you've had a chance to practice some of the different techniques that we learned in our normals notes.